Question 3 tutorial 10. In this question we have a certain parts of cast iron piping. This one is the material. So from cast iron, the material you have the roughness E. Of a water distribution system involves a parallel section. Both parallel pipes have a diameter of 30 cm. We have the diameter of two pipes the same, 30 cm, and the flow is fully turbulent. One of branch type A is 1500 meter long. This one 1500 meter long, while the other branch 2500 meter long. B, A and B. Okay, 2500 meter long. If the flow rate through pipe A, we have volume flow rate BA is 0.4 meter cube per second. You find the flow rate through pipe B. You find VB. If you ignore the minor losses and assume that water temperature is 15 Celsius, okay, so this question asks you find volume flow rate, and as you know, volume flow rate equal to velocity times cross-section area. Okay, so to find volume flow rate, it means you have to find velocity. And as you know, in the lecture slide, the subject coordinator mentioned about the parallel section. If you assume that this one is 0.1, this one is 0.2, okay, so if you write the energy equation between 0.1 and 0.2, and you will have the energy 0.1 will be equal to energy 0.2 plus energy loss. Okay, and because in this case we have two pipe A and pipe B, so the heat loss in pipe A will be equal to the heat loss in pipe B. It means you will have SLA equal to SLB. And in this case, because we can ignore the minor losses, so in this case we only have major loss, and major loss or friction loss equal to FA LA over DA VA square over 2Z equal to FB LB over DB VB square over 2Z. Okay, so as you know, dA equal to dB equal to 30 centimeter, so we can cancel out dA and dB, cancel out 2Z. Okay, with LA, you have LA is mentioned in the question is 1500 meter. LB here you have here is 2500 meter. About the VA, the velocity VA, you can find velocity from volume flow rate as pipe A, which VA equal to volume flow rate at A divided by cross section area A, or this one equal to 0.4 divided by pi times 30 centimeter or 0.3 meter square over 4. Okay, so the velocity in this case is 5.659 meter per second. Okay, and similar to question 1 and 2, F is friction coefficient. So FA, that's easy, you can find from E over dA and Reynolds number A, with Reynolds number A equal to rho VA dA over mu and Moody diagram. Okay, it means FA you can find, LA you can find, VA you can find, LB you know, you have to find VB. Okay, so to find VB you have to know FB. But how to find FB? FB you can find, you know, E over dB and Reynolds number B. E over dB, that's easy. Is you have the material cast iron, so you have the roughness E, dB 30 centimeter. So E over dB you have, but Reynolds number B equal to rho VB rho VD over mu. It means you can't find friction coefficient FB if you don't know velocity VB. Okay, so in this case, how to find VB? You can't find VB without FB, but you can't find FB without VB. So in this case, we have to use try and error method. It means we have assume as you know FB or VB. Okay. For example, in this case, I assume I have FB is a number A is a number. Okay. And when you have FB, based on this one, I call is a equation 1. Based on equation 1, I can find. Now when we have FB based on equation 1, you have FA, LA, VA, FB, LB, so you can find VB. Okay, and when you have VB, you know Reynolds number B equal to rho VB D over mu. You can find Reynolds number B. Okay, and when you know Reynolds number B and E over dB, based on Moody diagram, you can find FB from Moody diagram. And this one will be is the input for the next loop. Okay, and you can stop if FB is the end and FB is the beginning of the loop. The difference is smaller than 10%. 10% is accepted for fluid mechanics. Okay, and if the difference is smaller than 5%, is very good. Okay, so in this case, if we assume FB is FA, FA is a number. Okay, FA you can find from E over dA and Reynolds number A. After one loop, you will have VB is around 4.383 meter per second. Okay, and after that, when you double check this one, you see that FB, the difference between FB at the end of the loop and FB with the beginning of the loop is smaller than 10%. So VB is 4.383 meter per second is accepted. When we have VB, we have volume flow rate equal to velocity times cross section area B, or equal to 4.383 times cross section area is pi. The diameter is 0.3 square over 4. Okay, and this one is 0.31 meter cube per second. Thank you.